All right, in this last section, we are going to discuss the topic of if the sides of a figure are doubled, are the perimeter and the area doubled too? So we're going to start here with just kind of a discovery activity. It says figure B has double the dimensions of figure A. So I went from 2 by 3 to 4 by 6. And then figure C has triple the dimensions of figure A. So 2 times 3 is 6 and 3 times 3 is 9. And so we've got our dimensions. I've gone ahead and calculated the perimeter, adding up all the sides. So the perimeter of A, the perimeter of B, and the perimeter of C. And then I found the area, length times width, or base times height, 2 times 3, 4 times 6, and 6 times 9. Now we're going to start looking at what happens to the side ratio, the perimeter ratio, and the area ratio. We want to know what happens to the sides, what happens to the perimeters, and what happens to the ratio. So the relationship between A to B, remember that B was twice as big. It's 2 times bigger. So the side ratio, if you look, the side ratio is 2 to 4 and 3 to 6. So we have 2 to 4 and we have 3 to 6. And if you simplify both of those, then what you find out is that they simplify 1 to 2. That means the second one is twice as big as the first one. Okay, now my perimeter ratio, we want to see what happens when the sides are twice as big, because that's all I told you is that the sides were twice as big. My perimeter ratio is 10 to 20. Well, if you simplify that, divide both sides by 10, divide 10 by 10, divide 20 by 10, you get that that has a ratio of 1 to 2. Well, if you notice, look, your perimeter is indeed 2 times bigger. So when my sides were 2 times bigger, my perimeter was also 2 times bigger. But let's look and see what happens to our areas. Our area originally from A to B was 6 to 24. So if we simplify that, now by simplify I mean if maybe this will help me you see this, you can also write a ratio as a fraction. So 6 over 24 reduces to 1 over 4, and we can write it as a ratio of 1 to 4. So look at what happened. Notice that my sides were 2 times bigger, so my side ratio is 1 to 2. My perimeter ratio has that same ratio, 1 to 2, but my area ratio is 1 to 4. Now let's look from 1 to C, from A to C. From A to C, it is 2 to 6 is my sides ratio, and 3 to 9 is my sides ratio. Remember my sides originally, I told you they were tripled. So originally I told you they were 3 times bigger, which proves to be true, right? If you take 2 over 6, it reduces to 1 over 3. So my ratio is 1 to 3. Okay, well that makes sense. The smaller one is 1, the bigger one is 3. 3 times bigger. So let's look at what happens to our perimeter. So from our perimeter, it's 10 and 30. Well, if you write it as 10 over 30 like that, then that reduces to 1 over 3. So indeed, my perimeter ratio seems to maintain that same pattern. Whatever happens to the sides happens to my perimeter. So my sides were 2 times bigger in that case. My perimeter was 2 times bigger. My area was 3 times bigger. My perimeter is 3 times bigger. So let's check the area. Area was 6. My new area of my tripled figure is 54. That reduces to 1 over 9, or a ratio of 1 to 9. So what's the relationship there? Well, do you notice that 4 is 2 squared, and 9 is 3 squared. So what happens is if my sides are 3 times bigger and my perimeter is 3 times bigger, then my ratio of my areas are going to be 3 squared times bigger. Okay, now that kind of makes sense. Area is a two-dimensional, right? It is length times width, so it got twice as big and twice as big, or 3 times as big and 3 times as big, and 3 times 3 is 9 times bigger. So that makes sense. So in summary, here's what we come down to. Whatever your scale factor is, your sides are going to maintain that scale factor. Whatever the ratio is from your little one to your big one, or your big to little, whatever it is. Your perimeters are going to maintain that same ratio. Okay, so your sides and your perimeters will always be the same. So yes, if your sides are doubled, your perimeter will be doubled. But your area will be squared, a squared to b squared. So let's get some practice just converting back and forth between sides ratio, perimeter ratio, and area ratio, and then I'll show you how you can use it to find things that you don't know if you don't know side lengths or there's some piece of information you don't have about a figure. So if we start here with a ratio of our corresponding parts as 1 over 9, well, if it's 1 to 9, then the ratio of my perimeters, right, if we follow this pattern, then the ratio of my perimeters also has to have a ratio of 1 to 9. That means my sides are 9 times bigger, then my perimeter will be 9 times bigger. The ratio of my areas, right, is areas squared, so it will be 1/9 squared, which is 1 over 81. Okay, so that means my sides are 9 times bigger, my perimeter is 9 times bigger, and my area is 81 times bigger, 9 times 9. Okay, now what if I start by knowing the ratio of my perimeters? Well, I know that my perimeters and my sides have the same ratio, so my sides will have a ratio of 1 to 10. Now I'm just changing the way that we write the ratios just to show you that it always works. It doesn't matter how it's written. Okay, now if my sides are 1 to 10, then my area has to be 1 squared to 10 squared. 1 squared to 10 squared. So my area then will be 100 times bigger. If my sides are 10 times bigger, my perimeter will be 10 times bigger, and my sides will be 100 times bigger. Okay? Now, what about this last one? What if I start knowing the area? Well, if I start knowing the area, I need to come all the way back here to knowing something about the sides and then go to the perimeters. Now, the perimeters are going to be the same, but I just like to go back to the sides all the time. Always go back to sides. Everything's in relationship to what happened to the sides. Now, remember, this was squared. So what you want to do to go backwards is take the square root. Well, the square root of 9 is 3, and the square root of 25 is 5. So now my sides ratios, I have a ratio of 3 to 5, and I can use that to set up a proportion. Then I know that my perimeter ratios have to stay exactly the same. Whatever happens to my sides happens to my perimeters, and so my perimeter ratio will also be in a ratio of 3 to 5. Now let's look at how we can do this with some problems, okay? We're just going to start by knowing what's going to happen. Now look, I have sides, so what I can do is create a sides ratio. Well, my sides are in a ratio of 4 to 8, or I'm going to reduce that. 4 to 8 is 1 to 2. So my sides have a ratio of 1 to 2, or my sides are 2 times bigger. That means regardless of what these are, I know they look like squares, but they may not be. Regardless of what they are, I know that my perimeter will also be 2 times bigger. And my area will be 1 squared and 2 squared times bigger, or 1 to 4. So my sides will be twice as big. They are twice as big. So this is what I knew, right? This is what I started with. Then I know that my perimeter, whatever it will be twice as big. So if I tell you the perimeter of this one is 20, you can automatically tell me that the perimeter of this one is 40. Okay, if I tell you that the area of this one is 36, then you can automatically tell me that the area of this one is 4 times 36, which is 144. So that's the benefit, is I don't have to know any other measurements. I just need to know one relationship. Now on this one, find the scale factor and the ratio of the perimeters if you know that the two regular pentagons have the area of 50 and 162. Notice I don't know anything. I don't know the apothem. I don't know the perimeter. I don't know anything. But I know that they have an area ratio of 50 to 162. Now, that doesn't help me much because I know I'm supposed to take a square root, and those don't look like square roots. Well, let's do one quick check, right? 50 divided by 162, if we reduce that, look, there, that's 25 and 1 into 81. So we have 25 over 81. That looks a little more like what it's supposed to be. Now, that's not to say that you can't have numbers that are decimals. I can take the square root of 50 and the square root of 162. But when I can, I want to simplify it. So my areas have a ratio of 25 to 81. If I take the square root of both of those, my sides will have a ratio of 5 to 9. So I come all the way back here. So my sides, or my scale factor, is 5 to 9. And then I go to my perimeter, which also has that same ratio of 5 to 9. And then what we can do is set up proportions. right? So if I tell you then that one side is 10, then the other side has to be 18, because you can say, well, if it's 5 over 9, the small one is 10, how big is the bigger side? So with these ratios, once you know them, you can find anything you need to know about these shapes and by just putting in one other piece of information. So we can take this, the sides of an octagon are 8 times longer than the smaller octagon. So how many times greater is the perimeter? Well, remember, whatever happens to the sides happens to the perimeter. So my perimeter will also be 8 times bigger. Okay? So if I tell you the perimeter of the smaller one is 10, then you can tell me that the perimeter of the bigger one is 80. How many times greater is the area? Whatever happens to the sides squared is what happens to the area. I don't care what shape it is. It doesn't matter what shape it is. It will be times 8 squared, which is 64 times bigger. So if the sides are 8 times bigger, then the perimeter will be 8 times bigger and the area will be 64 times bigger. Okay, now let's look at how you can do this. So first, if we look at this, the figures below are similar right here. Find the area of the smaller pentagon to the nearest whole number if the area of the larger figure is 162. Now, here's where we run into a problem. There's a couple ways we can look at this, okay? So I'll show you both ways. Now, first, what I want you to notice is that what I have is a sides ratio. I have a 30 and I have a 10, and those are sides. So that's all I know, right? I know that my sides ratio is 30 to 10, or my sides ratio is 3 to 1, right? Or 1 to 3, depending on however you put it. I'm doing left over right. So one thing we need to do is, in order to be able to talk about the areas, I got to convert this. Well, this is in centimeters, right? That's centimeters. I need it to be centimeters squared so I can talk about the area. Well, remember what happens. Whatever happens to your sides, if you square it, that's what happens to your areas. So we're kind of completing this chart back up here, right? This was 3 to 1. So this will be 3 squared to 1 squared. So if I square them both, then my areas are going to have a ratio of 9 to 1. That means that this one is 9 times bigger than this one. So a couple of ways you can handle that. You can say 9 over 1, big over little, is equal to the area of the big one divided by the area of the little one. Now when you solve that, right, you cross multiply 162 times 1 divided by 9. You get 162 divided by 9 is 18. So we find out that the area of the little one is 18. Okay, or the scale factor is 1/9. It's 1/9 as big. If I had flipped this over that we were going from big to little, I would need to multiply by a number smaller than 1. So my scale factor is 1 over 9 going from left to right. Okay, so either way, you would find out that this area is 18 and this area is 162. But here's what's important. Remember, you had to start with your sides. You had to convert it so that you could talk about the areas. So if this is what happens to the sides, this is what happens to the areas. And then you can set up your proportion, or you can start to do the math to convert the measurement that you have into a measurement that you want. Okay, the area of a regular octagon is 120 feet squared. So we've got an area thing going on here. What is the area of the regular octagon with sides 1/4 of the length of the larger octagon? So my sides ratio is 1 to 4. I can't compare sides with areas. I don't have enough information to actually calculate the new area. So what I want to do is I want to convert. Well, if this is my sides ratio, then my area ratio is going to be 1 over 4 squared. 1 squared is 1, 4 squared is 16. So I have the area. What is the area of the regular octagon with sides 1/4 the length of the larger, right? And so this is my regular octagon, and I want to go 1/4 of the size. Okay, I want to get smaller. So I want to be 1/16 of 120. So I can take that 116, or you can do small over large equals small over large. We're going to assume that my regular octagon is my larger one, okay, because I want to get smaller. I want to create the smaller one. Okay, so we want to make it, we've started large and we want to make it smaller. So we just do this and we do 120, we multiply that, divide by 16, or multiply 120 times 1/16. So 120 divided by 16 is 7.5. So my area is 7.5 feet squared. Now again, you have to convert that sides ratio to the area ratio. But what I knew about was the sides. What I wanted to find out about was the area, so I had to convert. Now, this is useful in real life in this kind of situation right here. Okay, an architect draws a house plan on a grid with a scale factor of 1 square is 4 feet. 1 square represents 4 feet. Or 1 inch is 4 feet. You can do your scale as whatever you draw represents something in real life. But obviously you can't draw a full scale house plan, right? It's too big. That's the actual house. So my sides are in a ratio of 1 square represents 4 feet. So my sides are in a ratio of 1 to 4. Whatever it was originally, my new one is 4 times bigger. My perimeter ratio, remember, is the same. Whatever happens to your sides happens to your perimeter. So my perimeter will also be a scale of 1 to 4. And my area, remember, is square units. So 1 square on paper, side, length times width, represents 16 times bigger in real life, right? Because we're looking at length and width. With perimeter, we're just looking at length, so they're the same. With area ratio, we're looking at length and width, so it's 4 times 4, which is 16. So this is what it would look like. So if the house has a perimeter of 43 inches on the drawing, so on the graph, I have 43 inches or 43 squares on the grid. I want to know what my perimeter in the real world would be. If on paper it is 43 squares, what will it be in the real world? Well, my perimeter ratio is 1 to 4. Every 1 square on paper represents 4 feet in real life. So 43 squares on paper, 43 times 4. So you would take 43 and you would multiply it by 4, which is your scale factor, your perimeter scale factor, and you would get that your real world perimeter is 172 feet, right? On the perimeter, it's 1 square, so 43 squares on paper represents 172 feet in the real world. If the house has an area of 112.5 inches on the drawing, or squares on the drawing, however you want to look at it, 112.5 squares, right, on the graph, then, and this is squares squared, right, length and width of the graph, so it's actually the complete box, or inches, if you want to look at it as inches squared, then what is the real world area? Well, you need to use your real world, your conversion rate, right? My area is 16 times bigger than it shows on paper. So my area on paper is 112.5. If I multiply that by 16, then I get 1,800. So it's 1,800 square feet in the real world. You always want to double check, is that real world area, is it realistic? Well, houses definitely can be 1,800 square feet. I'm not sure what the average is. We could look that up on the internet. We can look it up somewhere and we can find out what it is. I would say houses range, apartments are about 1,000 to 1,200 square feet. So 1,800 square feet is a decent sized house. And you can go way up. Probably average would be probably 1,300 to probably 3,000 square feet. So I would say 1,800 is probably pretty close to being an average size. If you got something like 18,000, then something's wrong, right? That's really big. That's more like a store. So that's what we just want you to think about is, do these things make sense? Are they realistic in the real world? Okay, so in summary, what it comes down to is this. Whatever happens to your sides, the exact same thing happens to your perimeter. If your sides are twice as big, then your perimeters are twice as big. But whatever happens to your sides squared is what happens to your area. So if my sides are twice as big, then my area will be 4 times bigger.